Oh, is that it? Okay.
Speaker?
I was wondering. I couldn't figure out where his voice was coming. Oh, there's one down there.
Seminar, CS591S, here from Purdue University. Our speaker today is Ed Finkler. He's the CERIAS webmaster and archive administrator. He's going to talk to us today on real-world web app security. Ed?
Yeah. All right. Well, like I said, I'm the web monkey for CERIAS, and we're going to talk today about some stuff mainly related to open source applications, web application security issues, some of the problems that we're seeing today with them, some of the common attacks that people have against web applications, and some defenses, both code-based, techniques for setting up databases, servers, things like that, we're going to deal with. So, yeah, like I said, today we're going to cover basically the current state of open source web application security. We're going to talk about common kinds of attacks and some defense techniques to do that. I've got a lot of material, and I'm going to try my best to get through all of it. So I really want to encourage questions, but we might want to wait till the end. So if you have questions, write them down, and I will be glad to talk with you about that. If we run out of time here, you can just catch me sometime. You can catch me afterwards, or drop me an email or anything. I can babble about this stuff for hours. So, current state of open source web application security. Basically, as the popularity of these open source web apps has increased, the security implications of them has too. A lot of popular web apps have some really serious security problems right now. We're seeing large levels of installs of things like phpBB, Wordpress, things like that, and security problems with those are affecting lots and lots of people. The interesting thing with this is that actually most of the problems are fairly easy to solve. They're not particularly complex problems. They certainly wouldn't require a strong degree or strong interest in, say, computer science or things like that to solve them. But a lot of the developers who are doing open source web app stuff don't have a lot of background or education, especially in security issues. So how serious is this problem? It's a really big problem with open source apps that are based on easy to learn scripting languages. In the last 6 months, probably one that's come out has been extremely problematic is phpBB, which is it's a very popular free bulletin board app. You'll see phpBB on a lot of websites for people who are trying to put together communities. I did some fairly unscientific Google research with it, looking for sites that have the string powered by phpBB, which is sort of an identifier for it. From what I could tell after working with it a little bit, I think conservatively I can say that phpBB probably has about 5 million installs live on the internet right now. Now, in the past, so what are we at, about 8 months now? There have been 32 different vulnerabilities in the NIST National Vulnerability Database. That includes one that was kind of famous a few months ago called the Santy worm. The Santy worm was, as far as we know, was the first time that a worm had been used that affected web applications. It was an interesting piece of work. It basically would query Google to look for phpBB sites that were reporting a version number that was vulnerable to it, and then would direct itself at those, infect those machines, infect that install, and then spread itself from there. Let's see here. PHP Nuke, which is a very popular free portal application. Again, it's a community building kind of thing. With the same kind of fairly unscientific research, we probably see about 1 million installs of PHP Nuke. In the past 8 months, there have been 37 different vulnerabilities listed for this product. This Nuke has been notoriously bad with security. It's been around for a few years, and from the ground up, basically was not designed with security in mind. Being a community site, these kinds of things like phpBB and Nuke are really problematic because when vulnerabilities show up that allow attackers to get into, say, user databases and things like that, you're affecting huge numbers of people. You might have hundreds or thousands or tens of thousands of people with each one of these portals who can get impacted with that, who have personal information. People have a tendency to reuse passwords and things like that, and that has a really serious implication. WordPress, which is a really popular free blogging tool, it's a pretty recent product. It's got about 3 million installs. Generally actually has a very good track record for the most part with security. It's relatively low. It's only had 12 vulnerabilities in the last 8 months. They've been generally very good about responding to those things. It was notably, though, hit by CAN 2005-1921, which is a vulnerability in the pair XML RPC library. That was a serious one because a number of different products were based on it. Like I said, Serendipity, Drupal, Groupware, MailWatch, TikiWiki, PHP website, a bunch of stuff like that. Basically, that was a very serious one because it effectively allowed people to execute arbitrary code via XML RPC calls. And it was a vulnerability that affected a lot of applications. And even though it was patched almost immediately, there were a lot of sites that got hit by it. The nature of these vulnerabilities, like I said before, most of these vulnerabilities are really basic mistakes. They're not complex things. These aren't, errors in memory management. These are generally issues with things like input validation and dealing with user input. People taking advantage of developers not being familiar with that or not thinking about it. The shallow learning curve of a lot of these scripting languages, especially PHP, leads a lot of folks to pick it up quickly, which is nice. It's a powerful, PHP, for example, is a very powerful language, but it kind of lets folks who don't necessarily have a lot of background in these kinds of things develop applications that maybe not have an idea of exactly what the implications they are of the kinds of things they try to do. You often find with a lot of people who are doing development with this, concepts of client-side versus server-side stuff tends to get confusing. I see a lot of posts on mailing lists for PHP with folks who get confused about wanting to have PHP modify things that are in the web page when it's down on the client's system, things like that. I think that tends to add to some of the confusion. Security is often just not a top priority feature. That's probably not a new thing for a lot of application development, but it's definitely the case with a lot of web apps. And often these applications are installed by administrators with little coding or security education. These are kind of what you might call one-click install administrators. This is a menu from a control panel for a hosting system, actually a hosting system that I use and I like a lot. But they let you just go ahead and say you just a one-click install. You pick, I want to install phpBB, and you pick it and click it, and there it goes. And these kinds of things these apps are not, they're not being really aimed at other developers. They're aimed at end users. They're installed by people who probably don't have much programming skill and really don't have any intention of learning these kinds of things. These kinds of folks who are installing these things aren't likely to patch or keep up with updates, and it doesn't help the fact that most of these open source web apps, it tends to be difficult to patch stuff. They don't, you don't get let's say a lot of desktop apps will come with a patch that just comes as an executable. You run it, patches the thing. It's easy to develop patches for things like that. Most of these open source web apps, what you'll get is you'll just get a new version, and they'll say, well, they might give you a these files change list, but oftentimes the upgrade instructions are just upload all the stuff that's in this zip file except for the things that you changed, and don't change those unless it's one of these files. Then you have to change it. It gets very complex. But anyway, these folks, they just want it to work, and they generally do whatever it takes to make it work. They'll often rely on anecdotal evidence. Some dude in a forum is going to say, hey, Shema 777 star will work for me. And just to show you that's proof, that actually is from some instructions on getting a a blogging tool called Movable Type, which is written in Perl. These are instructions on how to install it on your OS X server. The instructions that he gives are actually, yeah, please make my library web server documents, which on OS X is a system level thing. It should only be writable by administrators. And the instructions actually say, make that whole thing world writable. It's not just a problem with PHP, I would say, but there are some caveats about that. PHP, why we're discussing it, two reasons. One, it's my particular area of expertise in terms of language, but also it's extremely popular. The vast majority of the tools of the web apps that we're talking about, I would say the vast majority of open source web app development right now is being done in PHP, and I would say it's probably going to be for the foreseeable future. I would say that PHP in and of itself is not necessarily insecure, and it's very accessible and very powerful, and that has attracted it. For a lot of folks, it makes it attractive. It means it drives a lot of popular web applications. It provides a lot of features out of the box. Sometimes a lot of those features, it's hard to necessarily count for all of them. PHP has, instead of doing things like forcing a user to include libraries out of the box to say, okay, I need to include my file IO library or my graphics library here, generally those things just come that are open to the environment all the time. So all of your functionality is available to you all the time. There are some features that have been put in PHP historically that have been problematic. The register globals feature, which automatically converts incoming data into a variable in the script level area, that has often proven to be a real problem. Allow URL fopen. What that does is that lets you use the file IO functions to access things over HTTP or FTP, things like that. That has often proven to be something that people have exploited. PHP is loosely typed, and that has sometimes been confusing. It gets especially confusing when you're dealing with input validation, things like that. And it does not have any kind of taint mode. Tainting is something that exists in Perl. It's something I know you can turn on in Ruby. I don't know that it's on by default. But basically, if you're not familiar with it, a taint mode in a language, basically the interpreter takes a look at where certain data is coming from and doesn't let you do anything with that data until you validated it. You basically have to do some kind of check and manually say, yes, this matches how I want to use it. Now untaint it and pass it through that, and then you can use it. But you can't do it without that, so it forces the programmer to be very aware of where it's coming from. PHP currently doesn't have any kind of tainting mode in it. There's been some research that's gone into that, but nothing has been incorporated into the core language yet. We're just going to talk about some common types of web attacks. These are the basic 5 ones that we're going to be dealing with. Spoof form submissions and HTTP requests are basically kind of the same thing. HTTP requests are basically a more complex version of it. Cross-site scripting, cross-site request forgery, SQL injections, and code injections. A spoof form submission, what that is it's basically sending some kind of arbitrary data to a script via manipulated HTML forms. It would be the case. Usually, the way that works is they can do a couple different things. If the HTML form is using the get method, then that's actually passed on the URL, and you can see a picture down here at the bottom. I hope you can kind of see it. Basically, it actually shows up in the URL as certain values that are passed along to it. Like in this example, it has a product ID and then the amount. Well, the amount might, if it's getting passed via get, might show up as 1, where you could change that to 1,000. Or God forbid somebody does something like passes like the price of an item over get, well, and it shows like $10, where you could change that to $1 or something like that. Those are things that hopefully anybody who knows what they're doing would catch, but you'd be surprised. It's slightly more difficult with post methods. With post, it doesn't show up in the URL, so it's more difficult in the sense that somebody just has to save out the HTML markup do some slight modifications to it and then send it. Anybody with an HTML for Dummies book can do that kind of thing. I mean, the basics of it, though, is that you can't expect that a user is going to utilize the form that you generate in the way that you expect them to. And that is something that, unfortunately, a lot of web developers miss. Spoofed HTTP requests are basically a more powerful form of form spoofing. It's less convenient, sort of. You kind of need to know what you're doing, kind of. Generally, it's going to require some kind of tool like wget or curl. Those are two different Unix programs that allow you to interact with stuff on the command line, interact with HTTP stuff on the command line. Or if you're really cool, you can just telnet to port 80 and just type stuff in. It's also pretty easy to write scripts that do these kinds of things with libraries like Pair's HTTP request. Pair is a repository for PHP libraries. HTTP request is a library that lets you do HTTP requests very easily. And the example here just shows you how to retrieve a cookie from a site. Make a request, get the response, show the cookies. It's really simple to do those kinds of things. So there's just isn't much difficulty in working with HTTP requests, and they're more powerful because you just have a lot more flexibility. You can work with the full gamut of HTTP to do different stuff to your scripts. Cross-site scripting is another kind of, and I'm not sure if I'd say it's the most common, but it's one of the most common attacks. Basically what it is that you're figuring out some way to inject content into a site. Usually it's client-side scripting. And it's usually used to steal cookie data because the client-side scripting stuff, like JavaScript, VBScript, and IE, those are the two main things, usually JavaScript, because that's going to work with everything. Basically what you do is you work with some application that hasn't done enough validation to strip out client-side scripting. And an example here would be somebody is running a guest book on their site, and somebody submits something that says, "Hey, dude, how you doing?" And inside this thing that they submit to the guest book, they put in a basic script markup. This here, location replace, that sends it to whoever Rick's page is, and then just passes as a value to some script that he's got on there the whole document cookie. Well, that's the whole cookie that was on that guest site, the guest book site's page. And it can get, that's a pretty simple example, but it's difficult to it's difficult to catch every situation where somebody might inject scripting unless you just remove it outright. We'll get to that in a little bit. But basically, again, the idea is that you're injecting some kind of stuff that's going to then get executed on the client when the person views a page, and then steal cookie data, things like that, which is one of the reasons why it's a really bad idea to put important stuff inside the cookie. Cross-site request forgeries. These are sort of the opposite of cross-site scripting things. Basically, the way these things are usually set up is you set the source attribute for an image tag, where in HTML somebody sets up an image there and you have a source attribute, SRC. That gives the person the address for where to get the image from. Basically, you set up and you pass an image tag in. You set the source attribute to a script that's on another site. One thing is that this only works with get method forms. But basically, the idea here is that you inject that to get it to trigger some kind of action via get on another site. A couple examples I've got here is the first one. You've got an image source posting there where instead of displaying a message, it could post some kind of subject to some kind of forum that says "CERIAS sucks" and or if somebody knows of a web application that exists behind somebody's NAT wall, they could set up something where if an action is again done by get, you got this terminate employee thing, and it could terminate employee ID number 123. Both of those are again examples where if somebody's able to pass in an image tag into your code and then or submits that to a web application, then that's displayed to the user. Well, then the user's client then will automatically execute that. The issue here is that HTTP is kind of a pretty simple protocol. It doesn't differentiate between whether you're asking for an image or you're trying to request a script or you're trying to request some kind of static, non-binary text, ASCII document. It doesn't make any differentiation between that. So an image tag, even though it's supposed to be an image, you can request anything you want to with it, and you can do stuff like that. An SQL injection, it's another example of messing with input. It's manipulating the input that's sent via any method, whether it be get or post or it's stored in a cookie, something like that, that's passed unfiltered into an SQL query. An example here is somebody passes, normally for the login, it might get, this is a real simple example that would be done via get. Login.php is something that processes logins to some kind of web application as passing username equals root or whatever. And then you're just manipulating what the value of username is, you're closing you're having apostrophe there to close it, and then you're inserting another SQL statement in here, drop table users. With a lot of databases, if they allow you to do multiple statements per line, what we're showing here is that because no one's filtering what's being passed in on username, well, that just gets passed into the SQL statement. Those things, that string gets passed in, the query gets executed, and I just deleted my user table. That is extremely common, are SQL injections. Again, I'd say most of the vulnerabilities that we saw in phpBB, php nuke, I would say 78% of those were SQL injections of cross-site scripting attacks. Code injections are basically like SQL injection, but you're passing some other type of code. That might be a PHP script that gets evaluated, shell commands, things like that. The eval command, the pair XML RPC vulnerability, that was an example of a case where people were able to pass PHP script that would get evaluated by the XML RPC library and run. And so people figured out a way to manipulate the strings that get passed in so it would pass any filtering that was on there, and it would execute the code arbitrarily. Exec and other shell calls are vulnerable to that if people don't do the proper kinds of input validation. And also things like fopen, include, and require. Anything that's working with paths on the system, it's pretty easy to manipulate those. It's where if you're taking user input and you're passing it to create, say, a path for what file to open or something to include or require, things like that, it's pretty easy to manipulate those so you can get it to display etc password or some other system file on there. These are some basic things with code injection. Both of these are working with the include statements, and where the web application is set up so it's using something that the user is passing in without doing any kind of validation, and passes that. So in the first example, they set up to include a certain page where, and the person manipulates that. So instead of using the page that the developer expected, he says, well, no, I want to get etc password off there. And because there's no checking done there, it goes ahead and includes it as text, and then that's going to be displayed back to the browser. What's worse, even worse, is the second example where if PHP's allow URL fopen is enabled, and evilscript.php on this site is just passed back as text, well, this include will just grab that off of the site, pull it in, and it'll be parsed as PHP. So then you can execute arbitrary code on it. So we're going to deal with some defense strategies here. We're going to deal with some code level defenses, filtering on the service level. When I talk about services, I'm talking about web daemons, databases, things like that. And then basically web services designs, how you set those things up to interact, and ways to deal with these kinds of things. With input, basically when you're dealing with code level stuff, for anything you just have to consider, with input consideration, that's what you have to take into account for any kind of attack. You have to think about for each one of the values you're dealing with input, what are you expecting? Are you expecting an integer? Are you expecting a particular format of string? Are you expecting one of a finite set of options? And in parentheses, I've put a couple things that are ways that you deal with that. If you're looking for an integer, you can do a test to say, in PHP, you do a test with to see if it's, use the isNumeric function. Because you have to, because everything that's passed in is actually going to be a string if it's passed in to the off of the input off the get or post payload. Everything's going to be a string, so you have to use isNumeric, which actually expects a string and looks at it and says, is this a numeric string, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, or not? And you would look at that, because something like isInt or isInteger is going to fail every time because it's not an integer, it's a string. Again, particular format of string, you would use some kind of regex to check against that. An example might be if you're looking for a person's, if the input is supposed to be somebody's last name, where there's going to be a certain number of characters, that's certain characters that's going to be made up of alphabet characters, maybe a dash, maybe an apostrophe, possibly a space, but that's basically it. It shouldn't include things like a semicolon or 2 dashes or an @ symbol. Those things should not be in somebody's last name typically. I don't know if anybody has one. So, and one of a finite set of options, that's easy. You just you use a switch statement or some if-else kind of construct to check against those. And you have to think about how the input's going to be used. Is it going to be in an SQL query? In that case, you'd probably want to process it with a prepared statement, or you need to run it through some kind of escaping functions first. Escaping functions that are particular to the database that you're working with. If you're going to use it in a system call, there's, well, at least in PHP, there's some functions that are specifically designed to escape stuff that's going to be used for that. Escape shell command, escape shell arg. Are you going to use it in a URI? Then you probably, you need to URL encode it. That uses special encoding that is appropriate for passing things via that. Or if it's going to be displayed to the user, you want to use something like HTML entities. Again, that's a PHP function that converts characters that are used in HTML to the entity markup, so they're displayed literally to the user and not. It doesn't say interpret it as HTML. The browser doesn't interpret it as HTML. I mean, at the essence of it, you have the real question is anything safe that you're going to get? And the answer is no. You really can't ever assume that any kind of input you're getting is safe. Anything that's coming from outside your code could be malicious. That can include things where oftentimes people don't think about this because they think, well, it's being generated by a machine, it's being generated by a computer usually, so an XML feed is going to be okay. Well, not necessarily. Somebody could easily just pass something in there. And I've seen a lot of web developers who will are very careful about checking what you say human code that comes in via get or post. They're very meticulous about checking those kinds of things, but don't check things like XML feeds that they pull down to their site and to incorporate content. That stuff you have to treat just the same way. Another situation is when you're dealing with sometimes a lot of, and I'd say maybe most web applications that are developed and used internally. So you're working with employees, and kind of the expectation is that, well, the employee's not going to do anything bad, right? Either accidentally or maliciously, employees can do stuff that's going to goof with things. They could just accidentally type something in that messes stuff up. They could hit the button the wrong way. They could interact with the application in a way you didn't expect. Or maliciously. It's very easy to get an employee who sort of knows some stuff about these things and isn't happy and decides to do something bad. One thing that occurred to me while I was working on this, although as far as I know it's not been done, there's really no reason that a piece of spyware that existed on, well, usually a Windows box, a piece of spyware that exists on an employee machine could attack a web application. Lots of spyware interacts with the browser. There's no reason that it couldn't say, somebody couldn't write a piece of spyware that infected an employee's machine, and then you're behind all your firewalls and stuff like that. You're working on a trusted machine, and could easily go in there and wreak havoc on a web application. And that's why you don't trust employees. So I'm going to talk about some basic scripting practices against some of these attacks. Again, my emphasis is going to be on PHP, but these concepts should be applicable to pretty much any of the major scripting languages you're working with, or other kinds of things. PHP has peculiarities about it, but it's where my background is strongest. And again, lots, if not the majority, of this work is being done in PHP. Protecting against form spoofing, a basic thing with that is you need to limit acceptable input in any way you can. This is an example, a simple switch case statement structure. Realistically, this isn't just something that you protects against form spoofing. This is something you should be doing against any kind of attack with any kind of input. If you can limit the kinds of things that you can expect, you should absolutely limit it. It should only be allowed these certain things, and you should only whitelist these certain particular values, and anything else should die immediately. It should just kill the. It should not be allowed to continue executing. Again, this is a basic case where you really don't have to do any filter. You're not doing any filtering in the sense that you're not manipulating the input. You're just checking, is it this? Okay, then do that. Is it this? Then do that. If not, die immediately. Again, you're setting, in this case, just 2 whitelist values, and then you're cutting out right away. Some other stuff with form spoofing. This isn't something that makes it impossible. It makes it harder in the sense that it raises the bar to some extent. Depending on who you talk to, if they really know what they're doing, they say, well, this is trivial to do. But realistically, most defenses are not going to rely, well, you better not, rely on one kind of defense against attacks. You're going to want to have a series of defenses, multi-layered defenses. And this is one way that you can really eliminate a lot of folks from doing stuff, is you use something called shared secrets to make spoofing harder. Again, it does not make it impossible by any means, but it makes it harder. Basically what you do is you make some kind of one-time hash, and you want to make it a hash that's next to impossible to predict. So you don't just MD5 something. You would say MD5 something with, there's a unique ID value, or unique ID function that PHP uses to randomly generate something. And you MD5 that, so then you've got a nice 32-character hash. You don't use a standard one because they're easy. You can, it's actually kind of easy to crack those, especially with MD5 libraries that are out there. But anyway, you create a hard-to-predict hash. You store it in your session, which is sitting on the server. And then you echo that out as a hidden field in your HTML form. So it exists on the client's machine as it says hidden. It's not really. I mean, anyone can just open up and view the source and see the value. But basically, for each time they request a form, they get a cookie. Each time they do that, they get a new hash. It doesn't make it impossible, but it really makes it harder. It makes it very hard. Shouldn't say that. It makes it harder to automate the process to some extent. Somebody really has to know what they're doing to do something to not use your form in this case. And again, it doesn't eliminate it, but it makes it harder. With the other basics with form spoofing is a couple things here to say that don't really work with it. CAPTCHA, which I can't remember exactly what it stands for, but it deals with the Turing. It's some long thing for Turing test stuff, where basically you have some squiggly-looking letters, and somebody has to look at that and type it in and say, okay, this is what it says. This says SMWM on it, right? Sort of. This really isn't effective against human attackers, but it's useful against automated attacks, and usually what you're trying to do is you're trying to defeat spamming with that. CAPTCHA stuff really is not effective against attacks against something in the sense of an attack where you're trying to find a vulnerability in an application and screw with it. The refer, which is in HTTP, that is supposed to indicate where the person who just arrived at your page, where they came from. That's completely not useful because that comes from the client and can be manipulated extremely easily. Anybody with a basic understanding of a program like curl or wget can change that. That is absolutely not useful, and you shouldn't even try to mess with that. Basically, again, the idea that you should be using for all of these is that you want to use multiple approaches in conjunction with filtering and sensible design. You don't want to rely on just one kind of thing. You want to have a multi-layered defense against your stuff. Protecting against HTTP spoofs, it's basically the same thing as form spoofs. If you design your stuff properly, if you think about how people are going to work with your stuff, you should be able to block it. If you've done your filtering right, it's going to work with this stuff too. The danger with HTTP spoofs is that folks can do who know how to do that can do more stuff and more complex stuff. This is where things like PHP's register globals setting gets really problematic because whatever they pass in, say via get or post, is automatically converted to a variable. If you're not initializing the values for your variables automatically, somebody could conceivably overwrite a value that ends up in your script. That's why you don't use register globals ever. This is protecting against cross-site scripting. Basically, the first thing is that you need to strip all potential client-side scripting out of any input that you get from the user. This is an example of how JavaScript can be embedded in almost any kind of HTML. This is just a bold tag. And you think, well, bold tag, it has no action associated with it. It doesn't go and grab anything. It's purely a formatting tag. Yeah, but most browsers are going to still have the ability to associate an action with it so that you bold this, but then you also associate this action on mouse over with it. And so if somebody has JavaScript turned on and they have this set up there, when they roll their mouse over the part that says, hey, look at me, it will execute this JavaScript, which is doing the normal thing that it showed before. It's passing. JavaScript grabs the cookie stuff out of document.cookie and then sends it off to this script existing on another site. Really, if you want to be smart about it, you should just eliminate HTML input entirely. It's generally, for most applications, you're going to be doing, most of these things are for forums, for guest books, things like this. If people are wanting to post content, they're just going to want to do formatting. So you should probably consider some kind of alternate markup set like BB code, wiki-style formatting, stuff like that. These things are much simpler, and you have the option to, because you're doing the interpretation from that markup language into HTML, you have a lot more control over what gets out and what doesn't. One thing that's interesting, again, this is specific to PHP, but just introduced into the pair library, I think 2 days ago, was an alpha version of this library called HTML Safe. What it does is it parses HTML, and what it claims to do is to strip down all potentially dangerous content within HTML. It strips out things like object tags, embed tags. These are things that you use usually for showing plugin content like QuickTime or Windows Media, things like that. Strips out any kind of JavaScript, any way that could be associated in there. That looks like a really useful tool, and I'm definitely going to be looking at that closely. Again, that's the URL for it if you really want to check it out. It's pair.phpnet/package/HTML safe. But you can just go to pair.phpnet and search for it there. Protecting with SQL injections. Basically, you're going to want to be, if you can't do some of the more advanced stuff, the basic thing you want to do is you want to use escaping functions like MySQL real escape string. What this does is this actually passes the string that you pass in to MySQL C library that does escaping for it. So you're doing it, that's what the MySQL developers said, this is how you escape stuff, you're passing it to that. Better ideas for databases that actually support it, like PostgreSQL, Oracle, MS SQL Server, things like that, is to use things like prepared statements. Those are nice because the escaping has to be done by the driver before it can actually push the prepared statement at it. That's the way that prepared statements work. It has to be escaped properly. So if your driver supports it and does it, it has to escape things properly. And that pretty much, I hate to say, I hate to make it'll never happen, but prepared statements should almost entirely eliminate the possibility of SQL injections. With code injections, really you should just never use something like eval. One of the PHP developers, I think it was Rasmus Ladorf, said that if eval is the answer, you're asking the wrong question. Basically, there are very, 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 very few situations where eval is ever going to be the good way to do things. So you should really rethink it if you ever think that you need to use it. You have to be careful with file uploads. I've seen some stuff where there was a vulnerability in one app where they weren't doing proper checking against against file extensions. So somebody where it was a part of a web app, you were supposed to be able to upload images. Well, it didn't properly check the extensions on things. So somebody could upload something with a .php extension, and then because of the way the web app worked, it could then execute that PHP. Well, again, that's simple input validation, but you have to be careful with file uploads. File uploads get especially bad if you have register globals turned on. It's really, really bad. You should, again, that's another reason, never have that on in your scripting environment. And I would say, if at all possible, you should avoid the use of user-submitted data in shell calls. Shell calls, anything dealing with files or any kind of, say you're calling a shell, calling some kind of shell command. If you absolutely positively must do it, you have to filter and escape with extreme prejudice. You should never, ever let stuff, don't ever take it lightly if you ever have to pass stuff to the shell. This is a simple example of where you're getting a remote user thing in the server array, and to do that, and you're looking up like somebody's home directory. For some reason, your web app is doing that. And I guess I could probably imagine some cases. Basically, what we've got here is this: you're using a Perl regular expression library stuff to match against the username, and basically it says if it does not match these characters in here, then it should die immediately. That is something where, again, as Pascal Mayonnaise pointed out to me, you want to whitelist stuff where there are certain characters that are allowed, and if it has a character that is not allowed, that is not whitelisted, then it should die. That's a better approach than blacklisting stuff, because if you blacklist, there's a very good possibility that you're going to miss something. With scripting practices, you've got to filter your output. Basically, you don't assume that your input filters are perfect. That would be a really bad idea. You need to filter what's coming out of your application as well. You should assume that any user created content, even stuff that you have filtered, even if you're the best, most kick-ass filtering dude in the world, you should never, ever assume that it's not tainted. Some PHP functions that are useful for that, HTML special chars. What that does is that converts things like the less than, the greater than signs. If you have the end quotes constant passed to it, it will escape quote marks and apostrophes, and it basically strips that stuff out. It makes it much more difficult for somebody, if you've missed something, it basically strips that out, so any tags that they've tried to pass in, it'll make them so they can't be executed by the client. HTML entities essentially does the same thing, but it does a more advanced version, but the security implications are basically the same. And again, as I mentioned before, you need to encode anything that you're going to use in an URL. You need to encode that properly. PHP has a nice function for that called URL encode. I want to mention, I mentioned tainted modes before. Languages like Perl and Ruby have these tainted modes where the interpreter limits what you can do with certain stuff based on where that's coming from. That's a really useful thing. There's a tainted mode that some research has been done on with PHP, but it's not really clear that's going to be in the main distro anytime soon. Hopefully, they will seriously consider that. I don't have a lot of time, so I'm going to kind of go through this stuff quickly, which I have been anyway, but even quicker. Service level filtering. A really, really, really cool well, actually, it's a module for Apache. It's called Mod Security. It's described as a web application firewall. What it does is it scans all of your incoming data, and one of the things that sets it apart from other approaches is that it can also scan post data that most of the other techniques can't. It also works with HTTP and secure HTTP. There's a couple examples here of these are filter rules that you set up with Mod Security. The first one is just it's going to strip out a drop, the text drop, and then if there's some kind of space in there, and then table out of any incoming data. So that means anything that shows up in a cookie and you get, post, anything else, it'll strip it out. The second one, it disallows JavaScript and anything except for something called HTML. So there's no way that any kind of scripting tags, I should say, it doesn't really strip JavaScript. It just strips out some kind of script stuff. It strips that out of anything except for some kind of variable that comes in called HTML. That stuff, Mod Security is a really, really good first line of defense that if you're operating any kind of web application, I would really strongly recommend you have that installed on your server. A couple other things you can do with it. It makes cheat rooting stuff really easy. That's quickly, that's something where you set it up so that the binaries can't basically go above a certain level in the file system. Normally with Apache, that's actually a very complex thing to do. You have to do a bunch of stuff at compile time and mess around with a bunch of stuff, and it becomes complex. And people like me aren't very good at that. That's all you have to do is that one command to cheat root Apache if you have Mod Security installed. Much easier. It also makes changing the server signature easy. That's actually a lie here. The guy who developed Mod Security said that it's not necessary to do with Apache 2. I forgot to correct this. You don't use mod headers. You want to do it with Apache 2 as well, because with mod headers, if it sends an invalid command, it'll still send the full thing. The server signature in Apache typically reports that you're running Apache, that you're running this version, and typically it will report things like, oh, I'm running PHP of this version. I'm running, I've got WebDAV of this version. I've got all these different modules installed of this version, blah, blah, blah. Well, you can just change that, again, with one command, with the sex server signature. And you can say, hey, you know what? I'm going to trick people, and I'm going to tell them it's Microsoft IIS. It's not really, it's not a way of really securing things, but it certainly gets people off your back a lot of the time. A lot of people criticize things and say, well, security through obscurity isn't security. Well, no, it's not, but it's not necessarily a bad idea when used in conjunction with real security, because it probably means you're going to have a lot less people attacking you. I'm going to deal quickly with some web services design. Hardware stuff, there are people who know this stuff better than I do. We're not going to deal with this stuff right here, but basically, firewall your stuff, structure your things properly, don't allow access from the world to your database server, things like that. These are basic things. Your stuff should be running behind a firewall. You should be restricting your traffic, basic stuff. A scripting environment, PHP is what I know, and I can tell you about it. Never turn on registered globals. That's a really, really bad idea. And never, ever use an application that requires it. There are still some out there that will say, well, you need to have registered globals turned on. That means that application is insecure. You should not use it. Display errors should be off. Log errors should be on. Typically, by default, PHP displays its error messages in the browser. If you leave that on, that means that you can expose information about your environment. Things like directories, how your file structure is set up and things like that. You turn on logging, and that logs out to a file. You turn off allow URL fopen. In shared hosting environments, Open Base Steer basically does something kind of like queue routing. It doesn't allow PHP to execute above a certain level. Disable functions, you can put in a bunch of things there to disable things like shell calls, things like that. With web servers, basically nothing should be in the document root that doesn't need to be. Your CGI bin stuff should be outside the document root. Any shared libraries, configuration files, especially stuff with passwords, should not be in the document root. There's no reason for it to be there, so you should never put it there. Again, with shared hosting considerations, I would never, ever run PHP as an Apache module on a shared host. It's very, very difficult to make it truly secure there. Even if you run the famous PHP safe mode, I would never do that. You should either run as a suexec PHP CGI, or there's another option. There's an Apache module called suphp that basically simplifies the process of suexecing a lot. Either one of those is pretty simple. With database servers, this is something, unfortunately, I'm not going to be able to get to too much. I don't have much time. The basic idea is that you should have need-to-know access for everything. You don't have to create a user that has read and write access if most of what you do is reading. You restrict users by IP. You create public users with read-only access, only connect with write access when necessary. And again, basic stuff we talked about, using prepared statements really limits your SQL injection possibilities. Build logic into the database server, not into your web application. It tends to be more likely that if you're going to screw up something like that, it's easier to screw up in your web app than the DB server. You should encrypt your connections between the application server and the database. And you should use things like stored procedures and views. Unfortunately, MySQL doesn't support that, and that tends to be a commonly used database. It's one of the reasons I don't use MySQL a whole lot. But views, especially read-only views, almost eliminate the possibility of damaging your data. Now, this is just some stuff with some tools. It's already about time to close up shop. I'm going to go. Now, these slides are going to be available on my homepage when I get back to my office and upload this thing. It has a number of different sites that you can look through, some different tools. That's my homepage, CERIAS. Right now, there's nothing there, but I'm going to go back to my office and put this stuff up. Just homes, CERIAS Purdue edu/COJ. And if you're interested in working on any kind of web app security-related projects, I'm a member of the PHP Security Consortium. We're looking for assistance in those kinds of areas. If you guys have interest in working on these kinds, especially developing tools to help people do things like auditing their web applications, looking for vulnerabilities, I'm interested in working with you on that stuff. So just get in contact with me. And that's it.